Hi guys, welcome back to my mathematics tutoring. My name is Peter C. Dr. Junior, math instructor at the University of Liberia and also your math tutor. So in this video, we want to look at finding the derivative of a function using the first principle of derivative or using the definition, which is this one. So we solved question 1 in previous example. So this is example 2. We want to solve a three-term problem, x cubed plus 5x squared minus 4. So to start with, since we have to use the first principle of derivative, which is this formula, our target is to replace f of x and f of x plus h. So the first thing we know from the problem, we know that f of x is equal to x cubed plus 5x squared minus 4. This one was given to us. This is it, right? So the next thing we need to know is f of x plus h. So your f of x plus h can be obtained from the given function. And how do we go about doing that? Is to just replace this x with x plus h. So anywhere we see this x that was here like this, like you see x cubed plus 5x squared minus 4. Where's where we see this x? We erase it and put x plus h, right? Where's where we see this x? We erase it and put x plus h. And the same thing with this one, we erase it and put x plus h. So you seen it? We use the same function, but we only replace x now with x plus h. So we put it within the formula f prime of x is equals to the limit of, now f of x plus h now is just this expression. So we write the expression x plus h raised to the third power plus 5x plus h minus 4. So this is the first one. So we have a minus sign there, minus. Then we write f of x. What is f of x? This one, the original function. Please always put it in parentheses because of the negative. So we have x cubed plus 5x to the second power minus 4. All divided by h as h gets closer and closer to 0. So our task here now is, okay, this is raised to the second power. Our task here is to expand x plus h raised to the third and x plus h raised to the second. So we're going to use the Pascal triangle. In the Pascal triangle, you have 1, 1, 1. Now, it says if you have a binomial x plus h, and then when the power is 0, whatsoever you have in there will just be 1. The coefficient will just be 1, right? If you have x plus h, and then the power is 1, the coefficient of these terms will just be 1, 1. Now for the rest of it, now you can determine it yourself. You just adding. So you rewrite this one, the first term, because the first term and the last term's coefficient will always be 1. So you rewrite this one and then you add 1 plus 1 is 2. Then you rewrite this. So this is x plus h raised to the second power. We continue because we need second and third. So we have 1, we rewrite this one. 1 plus 2 is 3. 2 plus 1 is 3. And then this 1. So this will now lead us to x plus h raised to the third. Now, those are the expressions that we want. This one and this one. So let's put it in. We got f prime of x is equal to the limit. So x plus h raised to the third power. This is how we do it. Pay keen attention. The coefficient for this first term is 1, so it's 1. Then we take the first term in this parenthesis. The first term here is x. So we say x, the highest power is 3, so we raise x to the third power. So we take the next term, h, we attach it to it, and raise it to the 0 power. Right? Then we move on to the next term. Yeah, 3. We come back here, x. So we drop the term, the power, to 2, and then we increase the next term's power, h to the first power. So that's a technique. Plus 3, we drop this x power by 1, it goes to 1, and we increase this 1 by 1, it goes to 2. Plus the next one, that the coefficient is just 1. So x now will go to 0, and h will go to 3. So we finish expanding this one, move to the second one, plus 5, parenthesis opens. So it's x plus h. So this is it. X plus h raised to the second power. So the coefficient is 1. So we take x, we raise it to the highest power, which is 2, not 3 now. This is 2, plus the middle term is 2. So if x is raised to the second, then it means h is raised to the 0, right? Plus 2x to the first, then h increases to the first, plus the last one is 1. X now drops to the 0 power, and h increases to the second. So let's take this one from there now. It has no part to play. So we have minus 4. Then we move to the last expression. We multiply this negative by every term in here. So the negative will change all of the signs. 4. So this negative 4 and this positive 4 goes out. And then this whole thing is divided by h, as h is approaching 0. So f prime of x. So we can rewrite this expression. X raised to the 0 power is 1. H to the power 0 is 1. Anything raised to the power 0 is 1. X raised to the first power, h raised to the first power is the same as h. So we can just rewrite some of these expressions. So we have x to the third, h to the 0 is 1. We don't bother ourselves writing it. X to the second, h, 3x, h squared, x to the power 0 is just 1, is h cubed. This is 5x squared. 5 times 2 is 10xh. 5 times 1 is 5. X to the 0 is 1. And then h squared. Minus x to the third. Minus x, 5x to the second. Remember I told you whenever you expand from here, when you expand this expression, all of the terms within your expression without h, which is the denominator, will go out, will be cancelled from the problem. So x to the third power does not have h, so you check. X to the third can cancel this second to the last. 5x squared, it has no h, so you check. You cancel this last term. So we now left with f prime of x equals to the limit of 3x squared h plus 3x h squared plus h cubed plus 10x h plus 5h squared. Okay, that's the last term. All divided by h, as h is approaching 0. So from here, we can apply it in two ways. One, we could say every term divided by h, or we could say since h is in all of the terms, let's factor out h. So in the previous video, we divided all sides by h. So this one now, we're going to factor out h. So we say h comes outside. We just need h raised to the first power to come out because this is h to the first power. So h, so this one now, we left with 3x squared. H is already out. This one, we left with 3x plus 3x. H now is there to the first power. This one, h remains, but it just dropped to the second. 10xh, h is no more, plus 5h squared. So it just dropped to 5h. All divided by h. H and h cancel. Remember, h is approaching 0. So we can now say f prime of x is equal to the limit of 3x squared plus 3xh plus h squared plus 10x plus 5h as h approaches 0. Since there is no denominator now that will take the problem to infinitive after we apply the limit, we can now apply the limit because this is limit of polynomial function. So if we apply the limit now, we have the derivative of the function. Anyway, we see h, we replace it with 0. So yes, 3x to the second plus 3x times 0 plus 0 squared plus 10x plus 5 times 0. So all the terms of 0 go out. You just have 3x squared plus 10x. So if we further simplify that one, x and x is a common factor. We bring it outside. You're left with 3x plus 10. So given this function, x cubed plus 5x squared minus 4, this is its derivative. X times 3x plus 10, or 3x squared plus 10x. Thank you very much for watching. See you next video.